Hey folks, here to give a little bit of an explanation about how to calculate an expected value off of something called a probability table, or also known as a probability distribution. So let's first just give it a quick example. Let's say that we're rolling a six-sided die. So the first thing that I'm going to do is I'm going to do what's called declare my variable. So I'm just going to let x say that's the result of the six-sided die. So the first thing that I want to do is I want to set up what's referred to as a probability distribution table. And that's going to be broken up into two categories. The first situation is where I'm going to have x, and the second row down below it, that's the probability of x happening. Well, when we roll a six-sided die, we know we've got a pretty simple set of options. Well, we could get a 1, a 2, a 3, a 4, a 5, or a 6. We also know what the probabilities of each of those are happening. Now, in the case of a six-sided die, it's really easy. It happens to be the same all the way across. It's 1/6, because the probability of getting a 6 or is the same as a 4, a 3, a 2, a 1, etc. Before we go into how to calculate the expected value here, we do want to go over a couple of things. Okay, so when you're making your probability distribution, so probability distribution keys. Two things that you really got to keep in mind. All options need to be listed. The second thing that's really important is that you got to make sure that the probabilities need to add to 1. So probabilities need to add to 1. And the reason for that being is that there's if I roll this dice, for example, there is 100% chance of something happening. I'm going to get a 1, a 2, a 3, a 4, a 5, or a 6. Now, I know that you're saying to yourself, well, Mr. Creedon, what if it lands on the corner? Well, we're not paying attention to that part, okay? Give me a break. This is a perfect die, and nothing wrong is ever going to happen. We're always going to get a 1, a 2, a 3, a 4, a 5, or a 6. And I can just confirm this for a second by saying, hey, I got 1, 6 plus 1, 6 plus 1, 6 plus 1, 6, 1, 2, 3, 4 plus 1, 6 plus 1, 6. Hey, that's 6, 6, aka 1. Something is guaranteed to happen. So in the case of finding a expected value off of this case, what we've been doing in the past is we've been trying to figure out the average value in the long run. And in doing so, we've tried to take a look at here's what's happening over 100 games, and let's find the average. Well, in this case, what has actually happened is we already found what happened over the 100 games. We just divided that, and that's found inside the probabilities. So in order to find the expected value, what we can do is E of x, which stands for expected value, is going to equal, hey, this is a fancy symbol for the sum of x, which is the value, times the probability of x, also known as, so that's the probability of that value. So something that we might ask is, what's the probability of rolling a 3, for example? Well, that would be, my value in this case would be 3. The probability of that value would be 1 out of 6. So let's see what it looks like to actually use this formula. I might say that the expected value of x is equal to, I'm going to list my probabilities and the values that are associated with those. So I have 1 times 1/6 plus, because I'm finding a sum, 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. Note that the reason that I have all of these be 1/6 is because that was the case when we took a look at our probability distribution. So to go through the math, we got the expected probability of x is 1/6 plus 2/6 plus 3, 6, plus 4, 6, plus 5, 6, plus 6, 6, or 3, 6, 10, 15, 21, 6, or 3.5. So hey, what does this mean? On average, we can expect 3.5 points per roll of the dice. So that's an example of how to find the expected value off a probability distribution. What we're going to go through now is, hey, this is actually the first example on your asynchronous assignment, so you definitely want to pay attention. But it's also a case to take a look at setting up that probability distribution when they're not all the same. And again, just some additional reinforcement of that formula. So for our asynchronous assignment, just something that you want to make sure in each case, you're going to set up a probability distribution. You're going to determine an expected value, and you're going to use that expected value to answer some sort of question, some sort of scenario. So something I'm noting, just read it off once. You draw one card from a standard deck of playing cards. If you pick a heart, you'll win $10. If you pick a face card, which is not a heart, you win $8. If you pick any other card, you lose $6. What we're curious about asking is, do you want to play? So let's just first focus on the fact that we got a standard deck of playing cards. Based on last class, we remember that there's 52 cards. And in that case, there are 13 hearts, 13 diamonds, 13 spades, and 13 clubs. So if I take a look, if I pick a heart, I'm going to win $10. So if I let X not be the card that I draw, but if X is the amount won, sorry, that's embarrassing, won on a draw, then we're going to take a look at, hey, what's the probability that I win $10? Well, I win $10 when I get a heart. And so the probability in that case is 13 out of 52, or 1/4. Well, what happens in order for me to win $8? Well, I need a face card. Okay, so in the face cards, I've got that is not a heart. Okay, so now we got to pay attention. I'll switch my color for a second. So we're looking for a face card, which is not a heart. So in that case, I've got the Jack, Queen, and King of diamonds, spades, and clubs. So in total, I have 9 cards that fit that category. Jack, Queen, King of diamonds, Jack, Queen, King of spades, Jack, Queen, King of clubs. Keep in mind that we're not considering the Jack, Queen, King of hearts, because if I got a heart, I would have won that $10. So here I've got 9 out of 52. And then the question is, if I pick any other card, I'm going to lose $6. And this can be one of the reasons why it can be really helpful to actually list these off as fractions. Because I know that these need to add to 1. So I know that these need to add, my numerators need to add to 52. So I can take a look, hey, 13 over 52 plus 9 over 52 plus something over 52. Well, that's going to equal 52 over 52. And doing a little bit of algebra, I get that X is equal to 30. So I get 30 over 52, chance of losing some money. After I work this out, again, I remember I want to do the expected value of X is equal to the sum of X times P of X. So what does that look like? It's going to be 10 times 1/4 plus 8 times 9 over 52 plus, and then keep in mind your symbol, okay? Because this is a -6. You're losing $6 with a probability of 30 over 52. I'm actually just going to transfer my work down here. And the first thing that I might do, especially for the 30 out of 52, the 9 out of 52, is I might just turn these into decimals. So I might have 10 times 0.25 plus 8 times, just keep in mind, I'm going to go to 3 decimal places. So 9 divided by 52 is 0.173 plus negative 6. Again, remembering that negative. 30 divided by 52, 0.577. Once I do this, I get, well, that one's easy, 2.5 plus 0.173 times 8, 1.384. Hey, I'm adding a negative, so that's going to be a minus 3.462. And when I find that sum, I get a total of 0.422. So keep in mind, what does this mean? This means that in the long run, key phrase when we're talking about expected value, we can expect to win $0.422 per draw. So yes, I love winning money. Even if I have to win a little bit of money every time I draw, I'm just going to draw and draw and draw and draw and draw. So I start to stack up a little bit of money. And keep in mind, that's going to be over the long run. So if I play this game 10 times, I've won $4.22. If I play this game 100 times, I'm expected to win $42.20. If I play this game 1,000 times, that's $422. Now, admittedly, this might take a while. So something we want to consider is how long would it take this game to play? Is it worth your time? But because I have that positive expected value, I'm still looking at this as a favorable outcome for Mr. Creed. Anyway, hope this was helpful. Your assignment is going to be to complete 2, 3, 4, and 5. Again, I would strongly recommend that you take a look at question number 1 that we just did together as an example. And I hope you have a great asynchronous day.